Hello. Move my face. Should have done that before I hit start. All right, we are in section 1.4 now. So we're still factoring, but now there's an A term. A term makes everything a little more complicated. So just to get started, to my right page, solving ax squared plus bx plus c equals 0. So first of all, we need to learn how to factor them. So to factor ax squared plus bx plus c when a doesn't equal 1, we need to find more integers such that, well, this whole mess. Basically, what we're going to do here is a times c. We're going to factor that and make sure that whatever multiplies here, adds to b. Okay, so the factors that multiply to give me ac add to give me b. And let's just practice one. Example 1 is missing. That's odd. Well, that's not it. I must have accidentally deleted it. So let's just write it down. I have 5x squared minus 17x plus 6. Now, the first thing that I do is I look to see if I can factor anything out of my trinomial, and here I can't. So now I'm just going to do 5 times 6. 5 times 6 is 30. Yep. And negative 17. So I need things that multiply the 30, which is 1 times 30, 2 times 15. I think we found it. So if I have negative 2 times negative 15, I get positive 30. I add those together, I get negative 17. So here's where the factoring by groups is more important. With lesson 1.3, by the end of the lesson, we were skipping some parts, and we found some shortcuts. And now we aren't going to do any shortcuts. So I'm going to subtract that middle term. I'm going to expand that middle term into negative 2x minus 15x plus 6. And it doesn't matter what order this middle is in at all. Now I will factor by grouping. And that parenthesis didn't work out very well. So common to the 5x squared minus 2x is just an x. And I get 5x minus 2. When I have a minus there, I want to factor out a negative. And it looks like I'll be able to factor out a 3. And I'm left with 5x minus 2. These will always match if you've done it right. So I'm going to factor out 5x minus 2. And I'm left with x and minus 3. So there is my factor. So I've factored the trinomial into 2 binomials. All right, let's try again. That first example was actually where c was positive, and this next example is where c is negative. It's all right. We're still going to do the same thing. So I'm going to find out what a times c is, and that's negative 21. Yep. And b is 20. So I need 2 things that multiply to negative 21. How about 1 times 20? 1 times 21. It's all right. I can do math. One of those is going to be negative, and I need to add to a positive 20. So I'm going to make the 1 negative, because if I add those together, I get a positive 20. Now expand that middle term. 3x squared minus 1x plus 20x minus 7. Group. And I did it again. You guys are going to check all my mistakes. Miss Carly, you did it wrong. And group. So the GCF for this first binomial is just an x. The GCF for the second binomial is a positive 7. Utilizing that eraser a lot this morning. Okay, these match, so I know I did it right. Factor the 3x minus 1 out, and I'm left with x plus 7. Okay, got it. Guided practice. I guess we'll do these just to make sure. I have a negative 21 and a negative 20. So this is going to factor into 1 times 21, but this time the 21 is going to be negative, because if I add those together, I get negative 20. So 7x squared plus 1x minus 21x minus 3. Factor out the x. I'm going sort of fast, I know. And then factor out the negative 3. Okay, the binomial matches, so factor that out. And I'm left with x and a negative 3. I think we're good. 15 and 16. 1 times 15, if I add those together, I get 16. I don't like it when they use z's. Plus 1z plus 16z plus 3. Group. Z, 5z plus 1. And a 3. That's not right. Sorry, that should be a 15. You guys probably already caught that though. So if I factor out a 3, I get 5z plus 1. 5z plus 1 matches, so factor that out, and z minus 3. Okay, got it. Let's move on. Okay, we have more practice problems for the same thing, so let me see if I can just write down the answers for you if you'd like to practice more. This number 3, actually, a times c is 6, b is 1. 2 times 3, I can't actually get to 1. So this one cannot be factored. And then number 4, my answer is 3x minus 4, x plus 3. And I think I have 2 more. Number 5 is 2u plus 1 and 2u plus 5. Number 6, 4x minus 1. That didn't come out right. Okay, cool. Now, factoring special products. If the values a and c in ax squared plus bx plus c are perfect squares, check to see whether you can use one of the special factoring patterns that we learned in the last lesson. Okay, so let's try a few. Here, I think I might have the difference of perfect squares because that's a subtraction, and this is 3x times 3x, and that's 8 times 8. So I have a plus b and a minus b. Easy peasy. This next one, let's try it. This is 2y times 2y, and that is 5 times 5. So in the middle, it should be 2 times a times b, which is 10 times 5, 2 times a times b. I don't think so. 10 times 2 is 20. 10 times 2 is 20. I don't know what I was thinking. So this is a perfect square trinomial. So we're going to have 2y plus 5 quantity squared. And let's try this one. Since I messed up on the last one, let's make sure we got it. This one's going to be negative 1 times negative 1. So the middle should be 2 times negative 1 times 6w, which is negative 12w. So now we have the difference. The perfect square trinomial, but 6w minus 1 quantity squared. Cool? Cool. All right, I'm going to write down the answers for the guided practice so that we don't have to work through them. This is a difference of perfect squares, so it's a plus b and a minus b. Perfect square trinomial, 3y plus 2 quantity squared. Perfect square trinomial, 2r minus 7 quantity squared. Perfect square trinomial, 5s minus 8 quantity squared. You can always pause this video if I'm going too fast to write things down, right? 7z is another perfect square trinomial. And the difference of perfect squares, 6n minus 5, 6n plus 5. Perfect. All right, so let's go back to that A term and to see if we can simplify things a little bit before we start factoring. If I can factor out a monomial, when factoring an expression, first check to see whether the terms have a common monomial factor, right? If I can make every number smaller first. So looking here, I think it's the difference of perfect squares, but 5 is not a perfect square and neither is 49. But I can factor out a 5 first. And now I have the difference of perfect squares. So I can say 5, x plus 3, x minus 3. Okay, cool. This next one, I don't know. This isn't a perfect square, that's not a perfect square, but everything's even. So let's see if I can make it smaller. So if I factor out a 2, I'm left with 3q squared minus 7q plus 4. Okay, I don't have anything super simple, but my numbers are smaller, which will be easier to factor. Let's do a times c is 12. That factors into 1 times 12, 2 times 6, 3 times 4. And I'm trying to get to a negative 7. So if these are both negative, then I'm there. So I'm going to expand that middle term, minus 3q minus 4q plus 4. Now this 2 is just going to hang out until the end. Okay, I'm not doing anything with it until the end. Go ahead and factor by grouping. I can factor out a 3q, and I'm left with q minus 1. And I can factor out a minus 4, and I'm left with q minus 1. The q minus 1s match, which is good because they should. Q minus 1, 3q minus 4 is the final factor. Now pause for a second. How could we check this? Let's say I'm worried that I made a mistake. How could I check it? Well, what I would do is FOIL those two binomials and then distribute the 2 through your FOIL, through your new trinomial. And then you could see if you got the right answer. Okay? All right. Let me see if I have a new page. Oh. All right. I don't know if I can add a new page. All right, we're going to do C, and then I'm going to give you the answer to D. So C is negative 5z squared plus 20z. I don't know what's going on here, but I know I can factor out a negative 5. Whenever you have a negative leading, go ahead and try to factor out the negative to see if it helps any. So I'm going to try to factor out a negative 5z, and I'm left with z minus 4. Let's see. I'm not sure if that's right, so let's distribute it back. If I multiply these, I get a negative 5z squared. And if I multiply this, I get a positive 20z. So actually right there, I'm going to double check. I can't imagine what I would have done wrong, and I think I'm good. C. Let's see. Yeah, that is correct. There's nothing else that I can do. Number 4. All right. So that's your solution to C. Okay. And then D, yeah, I can factor out a 3 first. And I'm left with 4p squared minus 7p plus 1. I have a 4, but I need a negative 7 to add. So that'd be negative 7. So I think I have not factorable for that one. Okay? All right. So I'm going to write down your answers. Okay? Let's see, guided practice for just so that you can practice them on your own, or this lesson would be like an hour. And I don't think you want to see me do these things for an hour. Okay, I can't do anything else after that. I just factored out a 3 and I'm done. Number 14, I can factor out a 2 first. There we go. Number 15, I can factor out a 3 first. Cool. Oh, and then this one isn't factorable any further. So that's a 10. I'm trying to get to 8. 2 times 5, I can't get to 8. So you're done after this. So guided practice, I'm on number 16. First I can factor out a 4, and then I can factor into 2 binomials. Number 17. And number 18. All right, cool. Moving on. Now with the last lesson, we factored and then we solved. With this lesson, again, we are factoring and then solving. So nothing is different. We're still using that zero product property rule, where we take our 2 binomials and we set each one equal to 0 and then solve for the variable, just with algebra. So let's go ahead and try one. So here, see how it's now an equation equal to 0. So I'm going to do a times c is negative 24 to b is 10. So I need 2 things that multiply to 24. So I think 2 times 12. And if I make the 2 negative and I add those together, I get 10. So let's go ahead and expand that center term. Group. It's called factor by grouping. I'm going to take out, I think, just an x, 3x minus 2. And then I'm going to take out 4, 3x minus 2. So I have 3x, oh, sorry. I don't know what happened there. 3x minus 2, maybe I was writing too fast. X plus 4 equals 0. Now I have 2 binomials. The zero product property rule says that this binomial could be 0 or this binomial could be 0. So if I add 2 to both sides, I have 3x equals 2. And if I divide both sides by 3, I get x equals 2/3. Or subtract 4 from both sides. So those are my 2 solutions, my 2 zeros, my 2 roots. Those are all the words I could use. Oh, and there's a b. Let's see if I left, yep, I did. So let's write that one. That one looks a little more complicated, so let's practice it. Okay, we need this in standard form first. So let's move the 4p to both sides. Oops, too many p's. Negative 20p, and the 5 to both sides. Now look at your trinomial. Can you simplify it? Can you take anything out? I can. I can take out a 5. P squared minus 4p plus 4. Now a times c is 4, and b is negative 4. Now there's, unless I've made a mistake, no, 4p plus 4. Oh, this is a perfect square trinomial. Sorry. I was wondering what was going on. Sorry. So now I have p minus 2, p minus 2. If I set those binomials equal to 0, p minus 2 equals 0, p equals 2. I only have one solution for those. Okay, like I said, 7 examples with this one. So this is example 6. You have made a rectangular quilt that is 5 feet by 4 feet. So that's the 5 and 4. You want to use the remaining 10 square feet of fabric to add a decorative border. of uniform width to the quilt. What should the width of the quilt's border be? So I want to use the remaining 10 square feet of fabric to add a decorative border, okay? So what should the width of the quilt's border be? I know that I have, okay, I just need a little more space. I know that the area of the border is going to be 10. The area of the quilt and the border is going to be 4 plus 2x and 5 plus 2x. But that's too much, so I need to subtract out the area of the quilt, which is just 4 times 5. Because I want to figure out what x needs to be as related to the remaining 10 square feet of fabric. But I can't use this 4 and this 5 in the equation without subtracting it, because I'd be adding the area of that fabric twice, and I can't do that. That doesn't work. So let's do foiling. 4 times 5 is 20. That's first. Outer is 8x, inner is 10x, and last is 4x squared minus 20. Let's get this in standard form. Okay, those cancel out. I'm going to subtract 10 from both sides. Collect terms. So this is what I need to solve. Need more space now. I can factor out, it looks like a 2 to make all my numbers smaller. It's always easier to do math with smaller numbers. Let's see, negative 10 and 4. 1, 2 times 5. Looks like I made a mistake. 18, right there. Right there. Right there. So this is going to be 1 times 10 and 2 times 5. So if that is negative, we get 9. Haha. Whew, that was close. 2x squared minus 1x plus 10x minus 5. I just expanded the middle term. Okay, factor by grouping. X, 2x minus 1, 5, 2x minus 1, and there's still that 2 out there. So that 2x minus 1 match, so factor that out, and I'm left with x plus 5 equals 0. The zero product property rule says that this binomial can be 0 or this binomial can be 0. Actually, it's really important. I need to get rid of that 2 first. So I'm going to divide both sides by 2, and it cancels it out. It just disappears. It's magic. It doesn't disappear. Mathematically, we're canceling it out. So add 1 to both sides, divide both sides by 2, subtract 5 from both sides, and then think to yourself, can I have a negative measurement? No, you cannot have a negative measurement. That's irrelevant. Cancel it. That is what you're actually going to use. So the border's width should be 1/2 foot to use the extra material, which is the same as 6 inches of material. That was fun. Ooh, more paper. All right, factoring in zeros. So to find the minimum or the maximum or minimum value of a quadratic function, you can first use factoring to write the function in intercept form. Because the function's vertex lies on the axis of symmetry, the maximum or minimum occurs at the average between the zeros p and q, which is what we did 2 lessons ago. We had standard or factored form, except now we have y equals x minus p, x minus q, and the axis of symmetry was x equals p plus q. I say q, I think 2, divide by 2. And then you would plug that back into the equation to find the y value that matches the vertex. Okay, let's try it. It's our last example, and of course we get this one with a multi-step problem, which is fine. A monthly teen magazine has 28,000 subscribers when it charges $10 per annual subscription. For each $1 increase in price, the magazine loses about 2,000 subscribers. How much should the magazine charge to maximize the annual revenue? What is the maximum annual revenue? So we need to set up a word problem, and we do this just like we did last or 2 lessons ago. We know that our revenue is a function, and we're naming it R evaluated at X. Okay, and that's going to be equal to the number of subscribers times the subscription price. Goodness. So the number of subscribers, they say, changes. So it starts out with 28,000. And then every time they raise the price by $1, they lose 2,000 subscriptions. And then the subscription price would be $10 is what it's starting at, and raising it by that same dollar, okay? So let's go ahead and try to solve for this. I'm going to FOIL. First, it makes better sense to, we're just used to seeing things with the X first. Makes my head a little happier. Now I'm going to FOIL. So first times first is negative 2,000 X squared. Outer is negative 20,000. Inner is positive 28,000. Oh, X. X. And last is plus 280,000. Let's see if I did that right. So first, yep, outer, I added a 0. Inner, we're good. And then last, I added a 0. Cool. Gather your like terms in the middle. That middle is going to be, let's see, 20,000 minus 2,800. 200, that's 19, 18, 17, 17,200. $28,000, 280,000. Whew. Okay, those are way too big. I know I can factor out at least the zeros. Okay, that's all even. So I'm going to go ahead and factor out. I always factor out a negative when there's a negative leading. That leaves me with x squared plus, I can get rid of half of 17 is 15, 16 and a half. Nope. Sorry. Divide by 2. That would be 8, 52, 25, 26, 16. I think. But you take out the zeros. Oh my gosh. Get myself all confused. Okay, looks like I've made a math error. Okay, that's 3 zeros. I only did 2 zeros here. Okay, so that is not right. That should be 8,000, which goes here. So let's just that equals negative 2,000 x squared plus 8,000 x plus 280,000. See how complicated things can be when the numbers get bigger, especially when you're trying to collect zeros. Now, if I divide that, I get 4,000. Just going to double check. You can choose to giggle at me. It's just 4. See, I knew that was wrong. Don't worry, this is the last example. 2AD, 123, divided by 140. All right, so that's what we have to factor, which isn't that big of a deal. Remember, we're trying to find the zeros, so I set that equal to 0, and that means that cancels out. I divide both sides by negative 2,000. So really I need two numbers that multiply to 140 and add to negative 4. And that's going to be 10 times 14, where I want the 14 to be negative. So x minus 14, x plus 10. Set equal to 0, x equals 14, x equals negative 10. That should just be plus 10. All right, so we're trying to find what is the maximum annual revenue? So we know this crosses the axis at 14 and negative 10. The maximum is going to be halfway in between. So 14 plus negative 10 over 2 is 2. So at x equals 2 is my axis of symmetry. But what is the maximum? If I plug in 2 to the original equation, in that original equation, I'm going to write it down. I'm evaluating the revenue at 2. Let's see. I'm going to use this version. I factor it out to 2,000, x minus 14, x plus 10. But I'm evaluating at 2. So I'm replacing there and there. Handy dandy calculator, 2 minus 14 is negative 12, 2 plus 10 is 12. Multiply all of that out and I'm at $288,000. That is my maximum. Because remember, it's just the Y value that we are going to report as your maximum, just the Y value. Lots of papers. All right, we're not going to do the guided practice. I will be glad to give you the answers though. Negative 3 and 3 1/2. Negative 1 1/2. And negative 5. And then the what if, $12.50. Oh, we didn't finish that part of the problem. $312,500. Okay, I'm going up for a second, hold on. So we didn't finish this. That is the maximum, but that's going to be at a ticket price of $12. Not ticket, subscription price. All right, those little mathematical errors that I did in the middle, that's going to happen, okay? It happens when I live teach too. I'm not going to try to edit my video to make it go away. It'll be all right, okay? Good work today.